works with ArcGIS Online. We'll get started here in just a couple minutes. My name is York Groh. I'm the Mapping GIS Solutions Manager here at Duncan-Parnell. Joined today by Rami Naber, who's with Trimble Water and really an expert, especially in the GIS component and how things can combine together. Do remember our special offer from now until February. If your organization, somebody from your organization attends all of our webinars, then your organization becomes eligible for a free lunch. So I say that out loud so that if you're signed in today or maybe just called in by phone and we can't tell who you are, send us a message in the chat window so we make sure we acknowledge and record your organization. A couple reminders as we'll get started. This session is being recorded for a couple purposes. Number one, once it's over tomorrow, we will be sending out a recording or a link to the recording of the webinar. As well, there may be some who have not been able to attend today. So those that have registered will also send that recording to. And if you haven't noticed, all the recordings are on our website, on our blog. So if there are past recordings, we've been doing these since May, about every 3 weeks. So if you are interested in those past recordings, certainly look at those and feel free to take advantage of that. We have got everybody muted, and we will keep everybody muted throughout the webinar until right at the end. Feel free to use the chat window. A couple of you are already. And feel free to use the chat window to send any questions. Jeff Smith, also with Trimble Water, is with us today, and he'll be monitoring the chat window to help out as well. With that, I will turn it over to you, Rami, and thanks for joining us.
Thanks, York. And hello, everybody, and thanks for joining us today. And happy GIS Day. Jeff reminded me earlier that it's GIS Day today. So in the agenda for today's webinar, I'll cover an introduction on the utilities and public admin. We'll go through the Trimble Unity Work Management software and provide an overview on that and how it works with ArcGIS. Same with Trimble Unity Remote Monitoring software and Telog IoT for monitoring performance of assets and how it works with ArcGIS as well, and provide you a walkthrough of both software offerings focused on work management and remote monitoring. So the Trimble Utilities and Public Admin profile of digital asset and infrastructure solutions address electric, gas, water, and wastewater, also local governments, enabling optimal asset and infrastructure management and informed investment decisions based on accurate, reliable data and analytics that we offer. These solutions that we offer provide a pathway for to intelligent asset and infrastructure management, addressing various business workflows from mapping and data collection, enterprise asset management and work management, permitting, planning and design, network and distribution management, remote monitoring, IoT, constituent engagement and analytics. And our focus today will be on the work management, mobility, and remote monitoring IoT. So the Trimble Unity is a GIS-centric cloud and mobile software that offers a suite of applications and tools that support smart water management efforts. The product focuses on workflow and business process improvements with the added benefit of collecting better information for decision-making and regulatory compliance. The software is built on Esri technology and seamlessly integrate with Esri ArcGIS. We are releasing a new version of the software that adds support for web maps and ArcGIS identity, and I'll be showing you those capabilities today as well. So we have a web application typically used by office users, dispatchers, supervisors, and operations staff that plan work activities, but also monitor the progress or monitor the performance of the assets from the IoT sensors. And then we have a mobile software that's built with field technician in mind, with simple user interface, action-driven workflows, providing the tools needed for field technicians to improve their productivity in the field. We've done integrations as well that are more water-specific workflows. It integrates with our IoT sensors to be able to view data out in the field when responding to events. We've done integration that we released early in the year with walks to streamline the valve exercising workflow as well, and data collection. The mobile software supports various platforms, including iOS, so iPhones, iPads, Android phones and tablets, and Windows tablets as well. And it works offline when there is no internet connectivity. Field technicians can continue performing their work. They have full access to the GIS and their work assignments, and be able to collect data during emergencies or when there is no internet connectivity. So almost every aspect of utility operations and asset management depend on accurate data on the utility network assets, including their location, age, condition, and operating characteristics. So Trimble Unity integrates with the Trimble high accuracy GNSS receivers, providing the tools and workflows to capture 3D positions of network assets, ensuring that your GIS is up to date and accurate, to build on the foundation, because the asset network is the foundation for asset management and work management. So from that foundation, Trimble Unity can be used alongside with rugged devices or bring your own device as well, to be able to plan and work activities, field workflows to improve productivity, field efficiencies, customer service, and driving down operational cost. Improving data accuracy at the source, so validation rules, and to make sure that the data is validated at the source of entry. Improving, providing reliable data that can be used for later on for insights and reporting. Trimble Unity as well work management, Trimble Unity Mobile can integrate with other enterprise systems, including asset management and work management systems. We've integrated Unity with CityWorks asset management systems. We've done also integrations with SAP and IBM Maximo to be able to streamline field activities and assignment using a GIS-centric mobile application. So with Trimble Unity, it's few simple steps really to get started. And Trimble Unity is designed on the concept of apps and configurable workflows, apps that are focused on specific business processes and targeted to a group of users within the organization responsible for those workflows. They're action-driven that guide field technicians through the workflow, with intelligent data collection forms that guide the field technicians to streamline the data collection process. So step one, and I'll walk you through that in the software as well, is creating the smart data collection forms and workflows, and be able to then create an app in Trimble Unity that leverage ArcGIS and ArcGIS web map, for example, to bring in that data into the app, and then create the data collection workflows associated to those apps, and then be able to use these apps to plan work and dispatch work activities out to the field and perform data collection in the field, and then bring that data back for reporting and progress and analysis. We also leverage the ArcGIS platform for creating dashboards using that data collected in Trimble Unity. So we recently announced our add-on, which is the Trimble Unity Work Management ArcGIS Connector, which it's a native ArcGIS API. It's a feature layers that allow you to bring that data that's collected in Trimble Unity into ArcGIS, whether it's web maps or dashboards, providing insights for operational efficiencies geospatially using the ArcGIS platform, and be able to quickly create those maps and dashboards that you can share across the organization, leveraging the broader capabilities of ArcGIS. and providing native integration without any coding really, and be able to bring those dashboards and embed them as part of the Trimble Unity applications. In terms of the Trimble Unity Remote Monitoring and IoT offering, our Telog brand of IoT recording telemetry units, or what we call them RTUs, have been proven in the field over many years. They support a multitude of water and wastewater asset performance monitoring applications, focus on reducing leakage in non-revenue water and better manage pressure and on the distribution system. Also to proactively detect and minimize sewer overflows and environmental impact on the collection system. Those RTUs are rugged, they're wireless, battery-powered devices that are easy to install and cost-effective to maintain, and provide accurate, timely, and reliable data with near real-time alarms for anomaly detection. So on the water distribution, the Telog RTUs and sensors support monitoring flow using our insertion flow meter, pressure and pressure impulses or water hammers that can be detected at high resolution sampling to be able to detect those impulses and know where they're what's happening out in the distribution system, and be able to minimize those impulses and understand where the source of those impulses, because those can cause infrastructure failure and water main breaks. We also have water level monitoring on tanks and reservoirs as well. And on the wastewater collection system, the Telog RTUs and sensors support monitoring rainfall, open channel flow, using our new non-contact flow meter, level, and sewer overflows and lift stations as well. The RTUs can support various types of sensors as well. So if you have a sensor with a digital or analog output, it can be integrated and connected with the RTU using standard protocols, including Modbus or I2C and so on, to be able to bring that data into the platform and be able to monitor the performance and alarming as well. So with Trimble Unity Remote Monitoring, it's again simple to get started and get access to monitoring the performance using the Trimble Unity mobile app and web app to be able to configure and install the RTUs in the field with the sensors, set up any alarms and alarm triggers. And then we have pre-configured KPIs that we calculate, and you could configure those KPIs to update your GIS data as well. And I'll show you examples. And then be able to analyze and report on the asset performance using existing native built-in dashboards and telemetry reports that we have in the product, or by bringing in some of that data into ArcGIS to be able to create dashboards and insights through the ArcGIS platform. So similar to the Trimble Unity Work Management, we have an ArcGIS connector that we have as an add-on to the Trimble Unity Remote Monitoring software, which again is a native ArcGIS feature layer that allow our customers and to bring in monitoring sites, alarms, pressure impulses into ArcGIS to be able to create dashboards and web maps using that data, but also to be able to activate KPIs on monitoring sites and be able to store those KPI values in the GIS, providing real-time situational awareness of asset operational performance natively within ArcGIS, be able to quickly create maps and dashboards that can be shared across the organization that leverage the data collected using our IoT platform, and leverage the broader capabilities of our ArcGIS platform for the analysis and reporting. This is a list of some of the KPIs we have out of box enabled. So on the pressure monitoring, we can bring in daily average min max pressure values and store that in the GIS. And same with pressure impulses, categorized by severity, S1 through S5. This is key for once that data is in the GIS, then you could start analyzing the likelihood of failure on those assets based on condition of those pipelines, for example, based on number of impulses and severity of those impulses that are occurring. So with one of the things we've done recently, the integration we have released with CityWorks for our IoT solution, which we're calling the system of action. That data, when it's stored in the GIS, we could use the CityWorks operational insights to calculate the risk of failure and business risk exposure based on not just asset condition and repair activities, but based on also performance data that's captured through our IoT solution here. On the flow monitoring side, we bring in min-max average flow. We also bring in nightly flow, calculate the nightly minimum flow that can be used to assess areas of, or DMAs, if you have DMAs, where there's likelihood of water leaks and non-revenue water. And same with total flow. So if you have virtual DMAs or DMAs and you're monitoring flow using our insertion flow meter, we can bring in the total flow in, and you can calculate if you have consumption. You could do mass balancing and calculate non-revenue water there. And on the wastewater, same, we have average flow depth, and we also have peak capacity flow and depth. And same with total rain as well, rainfall. So with that, I'm going to go ahead and jump into the walkthrough. Let me just minimize this screen here. All right. So here, I'm logging in to Trimble Unity as an administrator. So once we deploy Trimble Unity for a customer, they would need to configure, or our partners or our professional services team can configure Trimble Unity for the customer. So when you log in as an admin, one of the things you could do is set up the single sign-on with ArcGIS. So if you have ArcGIS Online or ArcGIS Enterprise with Portal, and you want to leverage the ArcGIS identity to log into Trimble Unity and use web maps, you would have to set up the single sign-on. And this is the admin screen where you set up the single sign-on, you register Trimble Unity in your ArcGIS Online organization, you get the client ID and secret, etc. And then you set up all the parameters required in this admin screen. And once this identity is configured in Trimble Unity, if we log out right now, you could see on the login screen, now you have the option to log in using your ArcGIS identity. So here, I'm going to go ahead and log in using my ArcGIS Online ID for the Trimble organization. And as I log in, I don't have really any apps configured in my organization at this point. So we'll walk you through how to create a new app in Trimble Unity focused on valve inspection workflow. So within the Trimble Unity App Builder, this is another admin tool sets that we have for the administrator to set up workflows and apps and data collection forms. These typically are set up once you have those apps configured and in place, then you could start using the software. So we'll start by creating a new form, data collection form in Trimble Unity. So we'll provide a form name, call it valve inspection, provide a description, and for every form in Trimble Unity, it has a geometry that you can capture. So if you want to be able to capture an accurate position of the valve while you're inspecting it, that can be stored, and then your GIS team can take that information and update your GIS based on the inspection records. So here, this is a point feature. We also have scoring capabilities for condition assessment. So in this case, because I'm performing a condition assessment on the valves, I want to enable scoring, and I want to automatically have the form calculate the condition score that can then be used for reporting later on. And also we have the option to enable creating a PDF report for every inspection that's completed as well. So once I provide my initial parameters here, I go to the pages, and this is where you could drag and drop certain type of questions you want to add and set up your form the way you want and the way you have your business process. So here I created a page called Valve Accessibility. I dragged and dropped the technician name, so this field will default automatically by the user that's logged in and performing the work. We'll add a yes and no question here to see if is the valve accessible, and we'll make this a required question, so the user will have to fill out this question before they can complete the inspection. Also, we'll add is the traffic control needed. And in this case, I want this question to only show up if the valve is accessible. So I'm creating a conditional question here, and this is where you set up that condition. So we don't want to give our field users everything on the form, only answer the questions that are required based on the setup of the form here to streamline the data collection process. So this will show you it's a conditional question. And then we'll add another one here in terms of a multi-choice, this case, where traffic control method, and we can add the choices in the form. And same as the other question, I want this to be a conditional question dependent on if the traffic control is needed, then I want to prompt the user to specify the traffic control method. We'll add a second page. This is where you can group questions into pages. This page is focused on the valve details. I added my geometry field for the valve location. By default, it automatically defaults to the location of the valve that's being inspected, but the user can update that location using high accuracy GPS, and that location can then be used to update the GIS. In this case, also I have a valve type that I wanted to default based on my GIS layer. In this case, the valve type field exists already. I want it to be brought into the form as well. And I also want to bring the number of turns from my GIS into the form. This is an example. We also have support for 1D and 2D barcodes. What it does, it allows the user in the field to scan the barcode and it'll automatically populate the content of that barcode into the field. In this case, this is a 1D barcode that is configured to bring in the serial number just to show you that it's supported. It's used a lot by our customers that do mass meter changeouts where they scan the serial number of the meters as part of that workflow. We'll add the third page here for valve condition and just keep it simple. We'll say this is general condition. I want to enable scoring on that field. I'll put a weight for that field, and then for every option that's chosen by the field technician, we could specify a score and a color code as well. And this is a conditional question that I will prompt only if repair is needed based on the general condition. So now I've completed a simple form, data collection form, and Trimble Unity will go ahead and save that form. And once the form is saved, admins can edit that form. They can share it if they want to share it with other organizations. It'll give you a sharing code that you can import into another organization as well. Also, we have the ArcGIS connector link that you see on the top. which gives you a feature layer URL that you can bring it into ArcGIS to be able to view that data that's collected against that form in ArcGIS as well. So now that the form is completed, let's go ahead and I'll show you how you could create your own custom workflow as well. In this case, I'm creating a workflow for my work assignments. So it'll start with an open status, and I want to progress it into in progress. And from in progress, I want to be able to complete it and then close out the work assignment. And also while it's in progress, I want to configure the ability for users to be able to return it, which takes it back to the open status. And so those are the statuses, and for every to progress the work activity from one status to another, the user have to take an action, and those are the actions that I'm defining right now. And for each action, we could specify whether this action is applicable only in the field, in the office, or both office and field. And I'll show you how that all works out when we start using the application and the workflow. So here, the user can reopen the work assignment, which will take it back to in progress, for example. Now we'll save that work assignment workflow, and I want to create another workflow, custom workflow, that's more centered around the asset that I'm inspecting. So assets, when we include assets into the workflow, they start in pending status, and I want them to change to inspected when the inspection is done. And that's a Unity workflow. And then from pending, if they can't inspect the asset, I want to create here a custom status called not inspected. And that's in a not started stage. So the user in the field, when they go to inspect an asset, they have the option to inspect or cannot inspect. That's what they're going to see based on this workflow. All right, so now we've created the form, we've created the custom workflow, and now let's go ahead and create the app. There's a few steps required to create an app in Trimble Unity using this new app builder that we're releasing. One is providing the application name, provide a description for it, and give it an icon. So we'll just have an icon for a valve. And then the next step is, now that I'm already logged in to Trimble Unity using my ArcGIS identity, I will have access to web maps that are in my organization. And this is the list of all the web maps associated to my user account in my ArcGIS organization. So we can quickly search for a web map that I want to associate to this app. So we'll go ahead and select the water assets map. And that would be the web map that I will use in my application. Step 3 is to configure any dashboards you have created for your organization. For this app, you could associate one or more dashboards to an app that will be embedded within the app in Trimble Unity. For now, I will skip this because I don't have any dashboards yet. I don't have any data, but I'll show you how we can edit the app again to add a dashboard to it. Step 4, which is creating the workflow, and you can create multiple workflows in an app. In this case, I'm just going to create one called valve inspection, and it's going to use work orders. And this is where you specify the workflow template, and we will go ahead and use the workflow template that we have created. So here I'll choose the workflow template, and you could see the diagram of that workflow that will be used. And then here in the configurations, you can associate an action to a data collection form. But I will scroll down now and set up this workflow to be an asset-based workflow. So I want to be able to associate valves, water valves from my web map into this workflow to be able to dispatch valve inspection work orders. And I selected my workflow that we've created. And here where I say if the user clicks on inspect, prompt them to input the data on the valve inspection form that we created. And if they choose cannot inspect, I've created a form called cannot inspect, which is a simple form. They will be prompted to fill out that form. So now that this workflow is completed, we'll go ahead and save it. And again, as I mentioned, you could add additional workflows. And now the fifth step is assigning which users will have access to this app. I'll just go ahead and assign it to myself. And then final step is to publish the app. Now that the app is published, we can go to the app selector screen, and all users that have access to apps will see the apps they have access to in this screen. So I have access to two applications in this case, the valve inspection and remote monitoring. Clicking on the valve inspection, you'll see that there are 0 work orders right now. If I zoom into the map, I can see my web map. This is a web map I've configured in my ArcGIS online. In this case, I could see all the layers. I could see the legend, and I can change base maps from the default base map that was saved as part of my web map. There are various ways to plan work activities. You could do advanced asset search, so you could search for assets that meet a specific criteria based on the attribute information. Or in this case, I'm just going to do a quick, simple map selection in this area. And this is where it'll identify all the features within that polygon that I've drawn. And I see 11 valves in this area. I could further filter my selection and be able to see the attribute information. So here I'm just going to choose all 6-inch gate valves that are not hydrant valves. And that's driven by your data model and your GIS. So now I select these 3 valves that meet that criteria, and I can see them on the map, and I can simply click on create work order and create a work order to go out and inspect those valves. And you could see the work order type automatically defaults to valve inspection because that's the only workflow we configured as part of this app. And it'll default the status to open because that's the initial status of the workflow we configured. We'll go ahead and assign it to myself. You can add notes. You could specify projected start date. And if we scroll down, you'll see the list of the 3 valves associated to that work order in this case. Now that the work order is created, assigned, and it includes those 3 valves, let's go ahead and switch to my mobile app. And here you're looking at my iPad. Same thing as a user, you need to log in using your ArcGIS identity to be able to access the web map that the app is using. And as a user that have access to the valve inspection, I'll be able to see that valve inspection app, and opening that app, I can see the list of work assignments assigned to me on the left. I can organize that and filter and sort, and I can see where the work order is on the map. I have full access to my GIS data at that point. And then I can progress the work order. So you could see here it's in an open state, and based on the workflow we've created, I have the option to say I want to progress it to in progress. So we'll click on in progress, and now I have 2 options. I can complete it or return it based on the workflow we've created. And I can see all the detailed information. And going to the associated assets section, it will show me the list of the 3 valves I have, and each one is in pending state, and I can inspect or cannot inspect based on that workflow that we have. So as a field technician, I can see the location of those valves I need to inspect or work on. I can click on the first one on the map. I could see the full attribute information from my GIS and progress the workflow to perform the inspection. And when I clicked on the inspect, it brings me the valve inspection form that we've created earlier in the session. So you'll see the total score. You could see the technician name defaulted, If I choose yes, it's accessible, it'll prompt me to fill out the traffic control needed. If I say yes to that, then it'll prompt me what control method was used. Then we jump into the valve details. You could see the valve type is defaulted to gate. A number of turns did not default because I don't have any in the GIS. You could also capture GPS position of that inspection. You could see at the bottom here, we bring in the GPS metadata. So if I have Trimble Unity connected via Bluetooth to my Trimble R1 or R2 GNSS receiver, you'll be able to see that, and you'll be able to see all the metadata, including real-time correction sources being used and so on. We also store all the metadata as part of the form. The scan, this is a barcode field that we've added. So clicking on the scan will bring the barcode scanner using the camera. This is just an example barcode that we created. And then we complete the condition. Here it marked it as red because I specified repair needed, and I selected the repair component to be the valve. And then by default, we have the attachments where you can attach photos, videos, capture the map and redline it. All of those will be attachments on the form. So we'll take a photo here, and you could add notes to the photo or mark it up as well. And we'll go ahead and save it. And now this photo will be part of the attachment, and you could see the score is 60 based on what we have configured. And there's one question that is marked in red. Now we will go ahead, and you could see this inspection was completed. You could do the same for the other inspections. Just real quick on the third one here, I'm going to choose cannot inspect and show you how we'll bring the cannot inspect form, where I defined it to allow the user to input the reason, for example. And once that's done, the work order can be completed, and triggering the sync will synchronize the data to Trimble Unity on the cloud, or wait until the auto sync is triggered. And now back in the office, in the web application, supervisors and office users can see the status of those inspections, can see the forms collected, can see the total score for each inspection. And clicking on the inspections, they can see all the results and photo attachments and so on. And they can go from one form to another as well to see the details. And if you have permission, you could make changes as well on the attribute information. And once that's done, we can go ahead and close out this work order. And that was the last step in the workflow that we configured. So now that we have all of this data, using the ArcGIS connector for Trimble Unity Work Management, I configured 2 feature layers in my ArcGIS online organization that bring in my valve inspection data and my work order data. So now we can create a web map using these feature layers. So within a web map here, I could simply search for my feature layers. I'll go ahead and add my water assets. And we'll go ahead and add my valve inspection layer. And you could automatically see the 2 forms we've collected here directly in ArcGIS. And add my work order layer as well. And you could leverage the capabilities of web maps here by changing the symbology, creating filters, and so on. So I'm just changing the symbology of the valve inspections based on the general condition field. And for my work orders, I'm going to go ahead and create a filter to only show me my valve inspection workflows or work orders on the map, and add a different symbol for it as well. All right, so now that we have this web map, created, and you could click on any of the features. So here, clicking on the valve inspection, you could see all the data that was collected in Trimble Unity, including the GPS metadata, including the scoring as well, all from within ArcGIS. Now I can save my web map, and I already have created a dashboard. I don't want to go through the process of creating a dashboard here, but I've already created a dashboard using the data. And now I want to show you how you can embed that dashboard from within Trimble Unity. So we'll log into Trimble Unity again and go to the app builder, and we'll edit this app that we've created. And going to the dashboard step, we can associate that dashboard to the app. And all users that's logged into Trimble Unity, if they have access to the app and the dashboard, they'll be able to launch it from within Trimble Unity. So going to the dashboard here, it will launch my ArcGIS dashboard embedded. That summarizes the total number of active inspections, show me some details on the inspections and the results. So how many valves broken, you could filter and leverage the full dashboard capabilities that's offered in ArcGIS. All right, so that's for Trimble Unity Work Management. Now I'm going to jump into the Trimble Unity Remote Monitoring. And again, here we're going to go ahead and log in using my ArcGIS Online ID. And as I log in and go to the Trimble Unity Remote Monitoring, we could see the web map that I have configured for my app. On the left side, you could see the list of all the monitoring sites I have in my organization. We have a variety of pressure recording web sites and flow and level. You could go to the RTUs and manage the list of RTUs you own and which ones are not installed and the ones that have been installed on sites. And then any work orders, if you have Trimble Unity Work Management, you could configure your own workflows to respond to events and perform repairs or maintenance in the field as well. So here I'm going to go ahead and quickly search for a PRV site. And I wanted to show you a couple of examples of the data that's coming in from the sensors. So for every site, on the right side, you could see the site information, battery status on that RTU, when it was the last time the RTU called in successfully and the last time, and when it's scheduled to call next. You'll see the RTU with the detailed serial number and whether there's any pending configurations to be deployed. List of all the measurements coming in, whether it's, in this case, inlet pressure, outlet pressure, temperature, and other measurements that we bring in. And then we have the KPIs that can be activated on that site based on the site type. So in this case, we can activate our pressure KPIs, including impulse KPIs as well. And I'll show you later on another example with already activated KPIs. So let's go ahead and bring up the telemetry report for this site by quickly clicking on the View Default Report, which will bring the default telemetry report showing the inlet and outlet pressure for that PRV. And you could clearly see there's fluctuation in the outlet pressure based on the data that's coming in. We could view the summary, and you could see the inlet seems to be pretty stable, but the outlet, there is a min and max. There's a big range there. And there's a lot of capabilities here. You could change the date range, look through the data via tabular view or graphical view, and change the look and feel of this report. And there's a whole bunch of capabilities to create the report based on your business needs. So if we go out, I can show you real quick another, I'm going to speed up real quick here. This is another site, which is a flow monitoring site that summarizes my hourly volume, and I think it's a 10-minute interval flow data in one report. And you could see the total volume of water based on my time interval, and then a summary, statistical summary on the min and maxes as well. Gonna speed up. So the dashboard, we have a built-in system health dashboard that gives you a quick view of the health of your assets that you're monitoring. So if there are any active alarms or any historic alarms that have occurred and have been detected by the sensors and RTUs. Also, so on October 18th, in this case, we had a bunch of alarms that occurred, and you could drill down and see what alarm, what type of alarm occurred, on what measurement, how long it lasted for, and so on. And you could investigate further and open the telemetry report, or be able to dispatch a work order for somebody to go out and investigate, for example. And then we also have battery status. So this is where you can monitor the status of the battery and replace batteries that are in critical status or low status. And you could plan work activities associated to battery and maintenance on those sites. Sorry. And finally, with pressure impulses. So this is an example of the sites that have detected pressure impulses, and you could see the severity level of those pressure impulses detected. So in this case, site Country Club had 4 severe impulses and 57 S2 impulses. So if we go ahead and take a look at the measurement for this site, this is where you could drill into details to see those impulses that were detected on the graph and in a list, and be able to also load the high resolution data. Some of those RTUs that we have can sample up to 256 samples per second, and you can bring that high resolution impulse data into Trimble Unity, and you could see the signature of those impulses that can be damaging to water pipelines. And then be able to, if you have other sites in the area, you could analyze where it started, and then look if you have any pumps, any control valves in the area, and identify the source of those impulses to eliminate them and reduce the likelihood of failure on those pipelines in the area. So in this case, this site is located at Olson Drive here on Chicago Avenue. It's deployed on a fire hydrant. We configured that site to also record the average daily pressure on the hydrant layer and in the hydrant feature. So in this case, I've identified the fire hydrant, and you could see the pressure value. So if this data is shared across your organization, anybody who has access to that data can access that pressure data as well, pressure value. They'll see the value on the timestamp. And if we look at the KPIs on this site, you could see the daily average pressure KPI is calculated on a daily basis. And I have 4 hydrants and 2 water mains that I'm updating with those values. And we have 2 options for updating GIS data. You could update the GIS data, so you could add that pressure value on the feature itself. In the case with the hydrants, that's what I'm doing. With the water mains, we're actually created a related table in the GIS that gets updated based on my daily average pressure. So we're storing a record every day, and you could then analyze in ArcGIS, analyze the historic average daily pressure or impulse counts from within ArcGIS. So I'll switch now to show you within ArcGIS. Here I created a web map that brings in my pressure impulses, alarms, and sites. And I've already configured my data to store these KPIs in my GIS. So we'll open up the web map and you can see the monitoring sites on the map. We've created a heat map based on historic leaks, and you could see the areas of where many leaks have occurred. I'll bring in my impulse layer, and here I created a filter to show only impulses of severity 3, 4, 5 that have occurred past, for example, October 1st. And you could see the pressure impulse on the map in the area. So now we can correlate historic leaks. You could see there are a few leaks happened on this pipeline segment. There are severe impulses occurring that could be the result of those that caused these leaks. And then clicking on that hydrant, you could see the pressure data, but also if we were to zoom out and click on the water main, we have created related tables. And if we open up the related table for the average pressure, this is where you'll see the daily average pressure recorded in the GIS against that pipeline segment. So if you're monitoring flow and you have a DMA that's a polygon in your GIS, you could store your daily total flow into that DMA polygon, for example. That's another scenario. And in this case, we're bringing impulses, historic impulses on the water main in the GIS as well. And once that map is created, then we can also create dashboards using that data. So here I have a dashboard that I've created, and we can follow through the steps to associate that dashboard to my remote monitoring app. And you could quickly see that dashboard from within the Trimble Unity Remote Monitoring app. So let's go ahead and show you an example dashboard that I've created. So this is a system health dashboard, but we also can go to the Naperville water dashboard that I created in ArcGIS that summarizes, shows me the web map, shows me my average daily pressure in zone 1. I summarized all the alarms and impulses, and also historic leaks based on year installed and material of the pipelines. And you could have this dashboard be an interactive dashboard just using the ArcGIS capabilities. And I have another quick example here of another dashboard we've created that brings in my impulse data, customer complaints coming in from CityWorks in this example. So we could look at high pressure customer complaints, correlate those with my impulse and pressure alarms in the area or pressure zone, and looking at historic leaks as well, and have access to all of this data from within one dashboard that can be shared across the organization. So that's all I wanted to show today. Maybe we can open it up for questions.
Great, thank you, Rami. Yeah. Go ahead, Jeff.
Yeah, I was just going to let Rami know. I know he didn't have visibility to this, but we've had several questions come in, and I've been answering them directly to the group or individually. So we don't have any new questions that have come in that haven't been answered. So unless York, you can see something that I can't.
Oh, but I would encourage if anyone wants to unmute themselves and ask a verbal question, feel free to do that as well. I know Rami covered lots of different components of the system today, so you'll let us know now or later if there's any questions that any one of us can answer. Great. Well, I don't see anything else coming in at the moment. Again, if you do think of questions later, or If you watch the recording that we will send out and then have questions, certainly let us know. As you can see, there's contact information here on this last slide, so that'll be in the recording that you get as well. But you have our contact information as well here at Duncan-Parnell, and we can answer those questions or get them answered if you need to. But Rami and Jeff, we certainly appreciate your all's time today and your expertise, and we appreciate what you provided for us.
Thank you, and thanks everyone.
Thanks everybody.
Thank you, Rami.